we're now going to derive the derivative of sine of x, and in turn cosine of x, and the other trig functions. Now, we need to prove a little fact beforehand. This is a little bit technical, but it's still a nice application of the sandwich theorem, so I want to show it to you. Consider the unit circle here on the x-axis, or on the xy plane, rather. Right, suppose we have some generic triangle right here with angle theta. Well, we remember from before that if this is the side adjacent to theta, that's the same as cosine of theta, right, because of the unit circle, and that this is the opposite side, and then that's the same as sine of theta. And you know what, maybe I'll actually put this in here, right, because if we consider this triangle, try this right here, just sort of extend it a little bit. Right, let me try that one again. Okay, right, note that they're both right triangles. Okay, well, it turns out you can just use proportional reasoning to show that if this blue length right here is 1, then this right here is tangent theta. That side is tangent theta. Okay? So the reason that we care about that is that it turns out this, by definition, is our angle theta. Right, that's theta. Okay? Actually, let me put that in red. Just to be crystal clear, that's theta. Okay? So we have this inequality. Sine of theta is less than or equal to theta, which is less than or equal to tangent of theta. Okay? And we divide each of these sides by theta, I believe by sine of theta, sorry. Divide each of these by sine of theta, and we wind up getting 1 is less than or equal to theta over sine of theta. We're assuming sine of theta is positive, by the way. So we have that. We have tangent over theta, tangent of theta divided by sine theta. Okay? And then this is going to reduce to 1 is less than or equal to theta over sine of theta, less than or equal to cosine of theta. And then if you just flip everything, right, reciprocal wise, you get 1 is greater than or equal to sine of theta over theta, which is greater than or equal to 1 over cosine of theta. So we just kind of flipped everything. Okay? Now at this point, if we remember the sandwich theorem, and we consider the limit as theta approaches 0 of 1, I think that's pretty clearly 1, but it's also the limit as theta approaches 0 on, we'll just say from the right because it's positive, of 1 over cosine of theta, right? Because that's just 1 over 1, which is 1. So by the sandwich theorem, the limit as theta approaches 0 of sine of theta over theta equals 1. And so if you just substitute in a theta for an x, you see that you get that. Okay? So we'll just remember that that's true. Now, we're going to use this to prove the identity that the derivative of sine of x is the very, very nice cosine of x. What a beautiful relationship between sine and cosine of x. This derivation's a little bit long, but it's still doable. Okay? So we're going to start off with the limit definition of the derivative. Limit as h approaches 0, sine of x plus h minus sine of x all over h. Okay? Now, at this point, you do need to know the trig identity, which maybe you've seen before, that sine of x plus h is the same as sine of x cosine of h plus cosine of x sine of h. Okay, it turns out, I won't get into the identity, but it turns out this is the same as that. And so then anyway, we have the rest of this stuff right here, dividing by h over here. Okay, and so we're just going to group these two guys. Okay, just group those together. And so we're going to get sine of x cosine of h minus sine of x over here. And I'm just going to split the fraction. You'll see why in a sec. Plus, and then we've got cosine of x sine of h over h, right? And I just split the fraction up, right? I could have put it all over h, but I'm just going to do it this way, okay? And then we say, well, actually, assuming these limits exist, which we're going to show in a sec that they do, we can do this. Right, stick an extra limit in there. And then what we can do is we can say, well, I guess we have, oops, sorry, I guess we noticed that, right, by the way, I got this from that green stuff, right? I guess we noticed there's a sine of x that can be factored out. In fact, it can be factored out of the fraction altogether. So this is sine of x times the limit as h approaches 0 of cosine of h minus 1 all over h. And then this is plus, well, this is going to be, we can factor out that cosine of x, right? And we have the limit as h approaches 0 of sine of h over h, which we just showed was 1 by fact 1. So here's our answer of cosine of x. We just need to show that this limit equals 0. Now, how are we going to do that? Well, I'm going to use a little bit of trickery. Limit as h approaches 0. This is not what you might expect to do, but we're actually going to multiply by the conjugate. Over itself, of course, right? Let me actually emphasize that I usually like to put this in red. There we go, right? And so anyway, we know that this is just plus cosine of x, okay? And so we're going to wind up getting sine of x times the limit as h approaches 0 of cosine squared of h minus 1 all over this stuff. And then separately we have plus cosine x, whatever. And it turns out, remember our identity? Sine squared of h plus, or I used an x, but it's true for any variable. Sine squared plus cosine squared equals 1. Well, you can use that identity to show that this is sine of x times the limit as h approaches 0 of negative sine squared of h. And then what we can do is we can say, well, I guess that's really just sine of h times negative sine of h. And then this is going to be divided by h, and then this will be divided by the, right, I can always split the denominator over multiplication, right? We know that this goes to 1 by fact 1. And then we know that this just goes to 0, right? Because sine of 0 is 0. Right? And so if we just remember this cosine of h, we wind up getting cosine of x. Okay? So that's our derivative. That's how we show it. Okay? Now, using a similar approach, we know that the derivative of cosine of x is negative sine of x. And so then that would make the derivative of negative sine of x, negative cosine of x, and the derivative of negative cosine of x equal to sine of x. So what this means is that when we take the derivative of our trig functions, we get kind of a cycle, if you will. Right? If each time we take the derivative, right, we get derivative, right? We get all these derivatives, right? So if I ask you to find the 25th derivative of sine of x, right? Well, you might notice that 25 equals 6 times 4 plus 1. Every 4 derivatives, we repeat ourselves, right? Take the derivative of sine of x 4 times, you get back to sine of x. So the 25th derivative of sine of x is going to equal just the first derivative of sine of x, which is cosine of x. Okay. Now, let's just derive a couple more derivatives, like for tangent and secant, okay? So for tangent, remember that tangent of x equals sine of x over cosine of x. And we're going to use the quotient rule. So the derivative with respect to x, derivative with respect to x of tangent of x equals, so it's going to be low d high minus high d low. I guess that's a negative sign. All over low squared. Oh wait, it looks like we've got a cosine squared of x plus sine squared of x. That's just going to equal 1 over cosine squared of x. All right, you see all of this reduces to 1 based on that identity. Very nice. And that's the same. Remember, 1 over cosine is the same as secant, so we actually write this as secant squared of x. Let's try drawing that a little nicer. There we go. All right, let's do a similar derivation with secant of x. Now remember, secant of x equals 1 over cosine of x, so we can actually use the quotient rule to derive this. So the derivative of secant with respect to x is going to equal, it's going to be low d high, so cosine of x, times 0 minus high d low all over low squared. And when you reduce this, right, this whole thing goes to 0. This whole thing goes to sine of x, and then it's over cosine squared of x. And this reduces to, right, if you think about it, it's sine of x over cosine of x times 1 over cosine of x, which is the same as tangent of x secant of x. So just kind of squeeze it in there. Let me get that in here. There we go. Okay. A couple more examples very quickly. The derivative with respect to x of root x cosine of x is going to equal, we take the derivative of the square root of x, which we know is 1 over 2 root x, leave cosine alone, and then plus the square root of x times the derivative of cosine of x, which is negative sine of x. And that's our answer. Okay. And last but not least, here, take the derivative. I'm just going to say the derivative is going to be cosine of x plus sine of x, right? Be careful with our plus and minus signs. Leave this the same. Plus, and then leave the first the same. And then take the derivative of the second. And there you go.